Hello, everyone, and welcome to the 2026 Senior Design Expo. My name's Blair. I'm a sophomore, and I'm majoring in industrial engineering.
I'm Jack. I'm also a sophomore, and I'm majoring in mechanical engineering.
And we're just going to go ahead and get started. Thanks for joining.
We're going to start over here. All right, hey guys, can you introduce yourselves for me?
Sure. I'm Marcus Cohn. I'm Princeton Eloy.
Could you tell me a little bit about your project here?
So our project is ECG shirt. So one of the main causes of death in America is heart disease. And about 80% of these heart disease deaths occur at the home. And we found is when you call EMS services, when someone has a heart attack, it takes about 8 to 10 minutes usually for the emergency services to arrive. But research has also showed that every minute that somebody goes without receiving treatment, it's about 10% less survival rate. So what we've developed is a shirt that people at higher risk for heart disease, they should wear this at night. And it has electrodes on the shirt sleeve cuffs that continuously monitor and send an ECG signal to a receiver here. And that's able to detect if they have an arrhythmia. And if it does, it will send an alarm to that person. And also it'll send it to a receiver that is stationed with the caretaker that's living with them, or can also alert EMS services, as shown here. And that just allows for immediate treatment to be received or the authorities to be called, as opposed to waiting until it's too late for treatment to arrive.
We're going to head over to Blair now. All right, thank you guys.
All right, and I'm with our second team. Can you guys go ahead and introduce yourselves?
Hi, I'm Alex. This is George. This is Onglu. For our project, we designed an algorithm that uses hold the mic. Oh, okay. That uses an API from OpenAI to predict the stock market using technical indicators that we pulled from the stock market, and also using news that our AI gets fed weekly. As you can see right here, we have the portions of your money that we think we should use to invest in these tech sector stocks. And here's how we perform relative to the SPY. We're comparing to the SPY because we focus on the tech sector, and all of our stocks are based on that.
Awesome, cool. Why'd you guys pick this project?
We wanted to make people money, to be simple. We wanted to. All of us are very experienced in the stock market, and we thought we could make it simpler for other people to get inside of it. We wanted to make some people some money, basically.
Awesome, I love it. Thank you guys. And back over to Jack.
Okay, will you guys introduce yourselves for us, please?
Yeah, my name is Alonzo.
My name is Max.
My name's Alfonso.
And what made you guys want to do this project?
This is actually part of, a combination between Ryder and the University of Miami. Ryder is a huge company that maybe you've never heard of, but basically most of the trucks that you see out on the road across the U.S. and even Canada, the companies that use them normally don't actually own them. So Ryder is a company that actually has them and then leases them out to all these clients. And we're helping Ryder make it as easy as possible for all of their clients that use their trucks to get to 100% maintenance compliance, which obviously is a little bit tricky, but that was what we were doing.
All right, thank you guys. We're going to pass it back to Blair now.
Okay, and I'm with our fourth table. Okay, can you go ahead and introduce your group real quick?
Hi, we're on Tether. Oh, hi, we're on Tether. I'm Alex Miller.
I'm James Agger.
And over here is Anna Sheridan. She's finishing up with a potential user.
Nice. And can you guys tell me a little bit about your project?
Yeah, so Untether is a voice memo-based anonymous social media app where users can rant, upload anonymously, and connect with like-minded individuals. It's made for people who need to de-stress and just feel like they're being heard. And you can also listen to rants that people are struggling with similar things as you and just really connect so that you feel less alone.
Awesome. What was your guys' favorite part about the project?
I would say just working together and seeing something go from a concept to a real usable app with people posting and commenting. It's a really rewarding experience.
Awesome. What about you?
I would say that this idea used to just be in my notes app, and I didn't think that it could actually become real. and we have 30 users currently active on our app right now. So just seeing it work out is really cool.
Yeah, awesome. Thank you guys so much. I like how you can see the prototype to the final version. That's pretty cool. Yeah. And back to Jack.
All right. Can you guys introduce yourselves for us, please?
I'm Nick.
I'm Andrew.
I'm Jake.
All right. And could you tell me what your favorite part about this project has been so far?
My favorite part has been working on the render. Took a lot of time, but it was the most fun part of it.
Yeah, my favorite part's been working with my team, especially in the wind tunnel. We got a super lot of cool designs and features to show on the flap, especially. So we're really proud of that.
My favorite part was certainly 3D modeling and then testing with my team in the wind tunnel.
Could you tell us a little bit about what the project actually is involved?
Okay, so our project is a redesign of the Gulfstream G500. It leverages CFJ or co-flow jet technology, which is an active flow control system, whereas most aircraft use passive flow control systems, which is just the geometry of the wing itself that helps control the flow of air. An active flow control system uses energy to aid in the manipulation of airflow. And essentially, this just keeps the air attached to the wing longer, meaning that it can achieve higher angles of attack without stalling. And so our project uses this to help our aircraft take off at about half the distance. On top of that, we put the same co-flow jet technology on the tail because it also improves control authority of the tail. So what that means is that with less size, it can produce the same amount of force. So that reduces the total drag on the aircraft and in turn increases the range that the aircraft has.
You guys, we're back to Blair. Right over here. Yeah, back to Blair.
Okay, and I'm with our next group. Can you guys go ahead and introduce yourselves?
Hi, my name is Annalise Hoffman. I'm Alexandra Garriga.
And I'm Alden Ridley.
And go ahead and tell me a little about your project.
So the Commencement Reimagining Project is a collaboration with the Enterprise Project Management Office here at UM, and our aim is to optimize and enhance the end-to-end commencement ceremony process here at the university. So after we analyzed some data and did some simulations, we recommended some things to improve the process. Some of them being a graduate training video, so graduates can be more confident as they cross the stage, as well as some staffing volunteering to optimize that whole process.
Yeah, and then last but not least, we were able to kind of streamline the process of graduates as they proceed across the flow, both in the undergraduate commencement ceremony and the graduate ceremony, because the graduate ceremony, they add on that doctoral hooding process. So after creating simulations of that, of those new processes with our recommendations, we found that we were able to reduce the error rate significantly, almost to zero, while maintaining the same like time on stage of the graduates.
That's so cool. What made you guys want to go out and do this? Were you at a graduation or?
Well, it's a pretty common experience that commencement ceremonies tend to go longer than the audience or graduates might want it to. And with this being very relevant for us who are graduating a week from now, we wanted to take our IE skills and continuous improvement to find ways to optimize and improve the experience overall for everyone involved at these ceremonies.
Awesome. Thank you guys so much.
Thank you.
And we're going back to Jack over here. Here he is.
All right. And if you guys can introduce yourself, please.
Hi, I'm Lindsay Vigna.
I'm Neil Daniel.
I'm Caitlin Pecoraro.
Hi, I'm Jake Rena.
And could you just tell me a little bit about what you guys have been doing for the past year?
Of course. I got it. So essentially, we've made a robotic surgery training simulator. Currently, if robotic surgery trainees or residents want to train their foundational skills, they have to use the actual big console, which costs like $3 million, and hospitals may not have very many. So therefore, they'd have to split time between training and doing actual surgery. So we've made a simulator. Therefore, the robot can be used for actual surgeries, and this simulator can be used for trainees who are looking to learn their foundational skills. So there's a video here. It shows like the modules that we've created. They've been created in 3D so that people can see like the actual things that are going on. And we've all had a great time doing this. Like, it's been a great experience.
What's your favorite part of the project been?
I would say there was a point in the project where we reached a real low. All right. The arms were not working as we intended. The gloves weren't working as we intended. But then, like, collaboratively, we all picked each other up. We were like, good job, encouraging each other. And at this point, the product looks exactly the way that we envision it. And I think that point of the project, once we've got everything together, everything works, we all can high five each other at the end of the day. That's been the peak of this entire thing.
Awesome. All right. Thank you so much. And we're going to head back over here to Blair.
I love the TV screen over there. It's very interesting. All right, and I'm here with my next table. Can you guys go ahead and introduce yourselves?
Hello, I'm Carter Hayes.
I'm Brian Rocchio.
I'm Caleb Schuler.
And I'm Ethan Lee.
And I'd love to hear a little bit about your project.
Can I hold it? All right. So what our project does, actually, I'll start off with the beginning. So when you're scuba diving, a diver, at least one person in your group, has to carry this spool of line with them. And what this does is it demonstrates to the surface that there are divers under the water. And whoever is carrying this has to keep the rope on them. It can get tangled, it could tear, and it can make a bad situation worse. And what we did is we built a drone. It is a USV, which stands for an unmanned surface vessel. And it's tracking divers from the surface and monitoring their position in real time to indicate to nearby boats that there are divers under the water. And what this does is it eliminates the potential risks of being tethered to a surface buoy and the potential dangers that could ensue.
Awesome. And what was the most challenging part you guys would say about this project?
Honestly, working with the budget that the school gave us, one of the big parts that comes to engineering is being handed a budget, wanting more money, and having to figure it out. So a lot of the components that we used, we kind of took from other areas of life and tried to incorporate. So like the sensors that we used are very similar to the backup sensors that your car uses. But by repurposing them and waterproofing them, we were able to use them for our application.
Super cool. Thank you guys so much. Thank you. And now we are going back to Jack. I love how in Miami, it's very, very interesting to be under the water.
All right. Sorry, guys. We're going to do a live stream. Okay. So could you guys introduce yourselves, please?
I'm Camilla Arias. I'm Christine Lara.
I'm Nicholas Lomagers.
And could you tell me a little bit about your project and what inspired you to go this way with it?
Yeah, so we've noticed that there's a big trend with ACL tears within athletes, just your day-to-day. So we developed Cruci Check, so to basically replicate the Lockman test. You can see here, this is our prototype, and we are basically distributing a force out and measuring your ACL laxity. But yeah, we were working with some volunteers to test your right versus your left foot, and we were able to make a comparative test and kind of establish your healthy knee baseline, which you can see up here. We established about 7.62 kilograms per volunteer, which is our healthy baseline, which is about 75 to 85 newtons, which is what you could be seeing in a Lockman test. We want to continue moving forward to working with a torn ACL subgroup and with an injured patient subgroup, and also move forward to working with like rehabilitation and being able to compare your knee and like with muscle atrophy, and yeah.
Awesome. Did you run into any troubles when you were designing the product or anything? What was the hardest part, I guess?
Working with different kinds of volunteers, like you have we're working with athletes, you're going to have really tall and slender, you're going to have a bigger like lineman, it's working with different like fat or muscle subgroups that we want to be able to measure through. That's definitely been our biggest challenge, and establishing where we can make like a healthy baseline numerical value for our weight. Yeah.
Awesome. All right. Thank you so much. We're going to head back over to Blair.
Awesome. I am with our next table. Can you guys go ahead and introduce yourselves?
Hello, how's it going? We're Haven AI. I'm Jacob.
Hi, Dylan Phi.
Gianna Scuteri.
And tell me a little bit about your project.
So Haven AI is a cybersecurity platform meant for a basic user, so it's approachable and easy to understand. We take these complex technical alerts and convert them into plain English so that they're understandable and actionable.
Awesome.
Happy to walk you through the platform here. So this is what you kind of install on your desktop. So it's a desktop application, And like Jacob was saying, you have 3 different main processes for your desktop and then 1 for emailing. So if we go through here, the first one basically is your apps and privacy. So it monitors all of your different apps and running processes on your computer, and also have the ability to chat with a chatbot about it if you don't know what something's happening. So say you have keychain access or file browser, something that the Haven AI doesn't understand, you can chat with it, and then you can actually decide whether it's safe or not. Same thing with files. So I ran a little sample script that kind of showed you how it would react to dangerous files and so whatnot. So as you can see here, like urgentpayment.bat, it has a long list in the back end, basically explaining like what files are dangerous, kind of what file types are dangerous, the names of the files, whatnot. So that's kind of how it like will tell you what like suspicious files are on the computer or whatnot. And then lastly, we have the network connection. So any network connection that's active on your computer, we see it. So there's a bunch of recognized services. So you have a bunch of well-known IP addresses that kind of we also store in the back end, give it to the AI, and so it knows that. And then if it doesn't know that, you have the ability to actually ask it, and it'll go through here, and it will actually go and use the. And so now it told you that it's a legitimate content delivery network, and so it's safe to leave running. And then the last big part is basically that we have also an email system. So I used a sample email that I created, and then I sent one that was kind of like an attempt as a phishing email. You're actually able to see all your emails, and actually saw this one and read through it and realized that this could be a phishing attempt. And so it flagged it as suspicious. And then also, it scans your email every 10 seconds, so you can get all of your recent inbox. So it makes it very easy to kind of keep track of everything that's going on in your computer. And the goal obviously was just make cybersecurity easier to the average person, the non-technical user. And also a big feature that we have is all the user's data is stored within your computer, so nothing is ever leaked to the cloud or to the back end. So that's how we can kind of enforce that security.
Awesome. Have you guys ever thought about launching this to the public?
We have. We've had a lot of kind of good thoughts from people that have come and check it out so far. I mean, we have some ideas, maybe giving it more of an administrator and an enterprise setup, where we can kind of maybe give someone the administrator access with the dashboard, and then their employees might be able to install Haven AI on their laptops, and then they would be able to monitor it through that. And also maybe a big tech company might want to buy it. But no, yeah. So there's a couple different routes we can go, but maybe, yeah.
Awesome. Thank you guys so much. That was super interesting. And now we are bringing it back to Jack.
All right. Would you guys introduce yourselves for us, please?
Hey, how are you? My name is Pedro Borja.
Shante Luis.
And Diego Alguin.
And could you guys tell me a little bit about what you've been working on?
So our project is based on wind-powered lighting for rural highways. So in a lot of rural areas, there's not much grid access, so there's not much lighting. So that is a big concern for safety in those areas for motorists, wildlife in the area. So we decided to make use of the winds that trucks make when they're passing by, to be able to power that light source to make it safer for other places for motorists and wildlife in the area. So we tested different helical wind turbine twist angles, and we came out with the best option of 60 degrees. Yeah.
Does it only really produce power off of trucks passing by, or do cars also have an effect on it?
Yeah, so our project mostly targeted trucks. We didn't really study cars. Mainly, I mean, I'm not sure why. I mean, that could be something we go into in the future, but we didn't really look into cars, but it's mostly trucks.
Awesome. All right. Thank you guys so much. All right, we're going to head back over to Blair here.
All right. This is very near and dear to me. Okay, guys, can you go ahead and introduce yourselves?
I'm Antonio.
I'm Adi.
I'm Parth.
And I'm Kayla.
And I'd love to hear a little bit about your project.
So basically, we're a concussive recovery tracking system. So what we saw a lot through high school and things like that and playing sports is that the hardest part of a concussion is the recovery process. It takes usually around 2 months, and it's really like subjective or different by a per person basis. So what we did is we created an app and basically hardware that can track your concussion recovery through pupillometry, balance, and a cognitive test. So basically, athletes, before they start a season, would take a baseline test, and after concussion, they can log the concussion in our app and perform these tests every day for the few days, and then maybe once a week, and then twice a week for 2 months. And they can basically track their stats of how they compare to their baseline, right? And they can see how close they come back to their baseline. So what this really helps with is providing an objective, like when they can go back and play, like when they're fully healthy. And it also provides doctors with actual data that they can look at when they're trying to make that decision. And yeah, that's basically it.
Cool. What was the most challenging part about this whole entire process for you guys?
Oh, sorry. I think the most challenging part was concussions. Like, there's nothing really that
like known about them that much that like you couldn't like we thought first we started with trying to like we want to diagnose them, oh we want to prevent them, oh we want to like return to play, but we realized that concussion is such a like into a hard field to go into that you have to like work where you can, and we found that this is a niche, especially on the younger level, that like especially specifically in high schools where we could attack and probably help people.
Awesome. Thank you guys so much. And now we're going right back to Jack.
All right, could you introduce yourself for me, please?
Yeah, my name is Zachary Carreño, and I am the project manager for our group.
So what has your group been working on for this senior design project?
Yeah, so our group has been working on a redevelopment of existing Publix. It was a one-floor Publix, and we have completely demolished the site, built up. Our first floor is going to be a Publix. On the other side is going to be a lobby. Then we have 4 floors of parking. We have residential units on top with an amenities floor, includes a gym, includes pool tables, study rooms, and on the top floor of the gym, we have a dog walking park. So you can come out, get more sun, walk your dogs. And then also as a peace offering to the surrounding residentials, we added a community park on the outside of our site as, you know, as a good welcome to the neighborhood. So people, you know, enjoy the building, come see the building. We also designed our building as a stair, so it's not as intimidating when you look at it from the outside, so at least it builds up.
That's awesome. How many people can the building house with the residential units?
So we have around 210 residential units. It spans from one bedroom, 2 bedroom, and 3 bedroom.
That's awesome. And is it close to campus?
Super close to campus. So the address is 2278 Southwest 27th Avenue. So it's right, probably a few miles away from campus.
That's awesome. Maybe some people will be living there. Yeah.
They have all our construction documents, so they can build this whenever they want.
That's awesome. All right, now we're gonna head back over to Blair, guys. Over here.
All right, and we're coming over here with a table with a super cool demo. So I would love for you guys to all introduce yourselves.
Hi, I'm Mateo.
I'm Victoria. Hi, I'm Joy.
And tell me a little bit about your project.
So basically our project is a multimodal NICU stress reduction system where basically we've noticed that within babies in the NICU, because their nervous systems are so sensitive, they're very susceptible to basically getting harmful factors of harsh noise and harsh lights. And we noticed that being in the NICU at the whole children's hospital, that they have really harsh fluorescent lights and there's constantly high noise levels. As you can see in our poster here, the recommended level is much lower than what the babies are actually experiencing. So we created a little MVP here of what an incubator would look like, of having tints on the outside and then having a smart sheet tint here where you can turn on and off so the nurses and clinicians and doctors can see how the baby is doing, and then turn it back off so that it blocks light from the babies. And you can tell it works because the lux levels that we measured were substantially lower than what it was before.
Awesome, love it. And what was your guys' favorite part about this whole thing?
I would say our favorite part was kind of learning about the smart tint on the top of the incubator, just learning about how the liquid crystals are scattered around when it's off, so the babies can't like see the light coming through. And then when you turn it on, the crystals kind of align so the light can pass through. That was really interesting to learn about, I think.
That's so cool. Thank you guys so much. And now we're headed back to Jack. Right here.
All right. Sir, would you tell me, first would you introduce yourself, please?
Yes, I'm Gianna, and then this is Kennedy here.
Awesome. And could you tell me a little bit about your project here?
Yes, of course. Kennedy, would you like to help me? Hi, I'm Kennedy. So basically what our project is, should I just take it? Okay, you hold it. So what our project is, in older patients, we see a lot of osteoporosis. And so if they fall and break a bone or something like that, when they go in for surgery, they're not like us younger individuals where you can tell the difference in the bone layers, in the cortexes. And so surgeons use those differences to determine how far that they can drill a screw or whatnot. But with older patients, they actually can end up plunging straight through the bone and actually damaging surrounding tissue, blood vessels and stuff like that, arteries, and actually cause more of a problem. So what we've designed is a code and drill combination. And so what this code does is we upload the CT scans of a patient and we can see where the fracture is. And from there, we actually draw a line where it tells us the depth of the bone. So you see like what the depth would be of this, how thick it is. And from there, we're able to figure out how basically what that is in millimeters. And that gets entered, ideally it would be entered to our drill, which from there.
Basically, once we know the millimeters of depth, we'll take a time of flight sensor attached to our drill, and we'll feed in that to our system, and it'll basically tell us when to stop before plunging. So it uses a laser sensor that goes basically off the surface of the bone or the sleeve that we have. And it'll let me know when I'm within like 2 millimeters of when I'm about to plunge through the bone. And then it'll tell me when to stop, and the drill will stop before that plunging can occur. Basically eliminates the factor of like going through the entire bone and the entire leg and rupturing other vessels and whatnot.
Awesome. I saw you guys doing a little demo earlier. Do you want to do it? Okay, yeah, awesome.
You guys might not be able to see this screen, but so what we're going to do first is the surgeon would line up where they're going to drill, and then we will zero it out.
I won't run it just because it's really aggressive.
Yeah, it gets really loud. So we zero it out, and then she's all good to go. You'll see.
It's showing the depth right there. I don't know if you can see on the live stream.
You see this light? What that light did was it basically came on when they were within 2 millimeters of plunging the cortical bone all the way through.
It works.
It is a real drill. It does work, but it gets a little aggressive. So.
Awesome. Thank you, guys. And we're going back over here.
Okay, and we're back over here at our next table. Can you guys go ahead and introduce yourselves real quick?
Okay, so my name is Gabriel Noble. I'm with Simon Jaimez, Kevin Morrow Quinn, and Akira Heath. We're doing molecular property prediction using machine learning. So we identified in this pipeline where we lose a lot of information. So we took that spot and then we added a quantum-inspired circuit to the standard pipeline. We changed nothing else. And here we have a live demo again with both of our models. We call our model the rotation head, and then the standard one is the bounded MLP. So here, when we do real-time inference, we see that we achieve better accuracy, so lower error, and we do this with the same number of parameters. So we achieve, again, better accuracy, and we also, if you look to our graph, we achieve this with less parameters. So it's kind of the twofold advantage that we're getting.
Awesome. And why'd you guys go about picking this project?
So we had some experience in quantum computing. We know in some situations, not all, the principles that come from it could give us an advantage. We knew in molecular property prediction, there are interactions that classical models sometimes struggle to capture. So we believe that quantum-inspired circuits would be a good kind of element to add to this pipeline. And again, we had experience in it, so we decided to go down that route.
Awesome. Thank you guys so much. And now we're going back to Jack right here.
All right, could you guys introduce yourselves for me, please?
I'm Gabriel Orejon.
I'm Braden McCullough.
I'm Gabriela Bueno.
And could you guys tell me a little about what you've been doing for your project?
So our project was a predictive model for the vegetation growth around the power lines. We partnered for FPL for this project. So essentially their issue is that their vegetation trimming is getting done on a 3 to 6 year cycle based on the area that the power lines are in. So this fails to account for the varying vegetation growth. So some
Hello,
trees grow
everybody.
slower,
I'd
some
like
trees
to make
grow
a quick
faster, So there's a
announcement.
lot of waste in
The
that
first
process,
round-
which, as you can see here in the red box, is what we essentially aim to fix in their current process. So they fly a plane over the state of Florida every single year, and they collect LiDAR data to see how close the vegetation is to their power lines. And then Braden can get into a little bit more of how we worked with that data.
Yeah, so essentially using the LiDAR data, we took data from 2022 through 2025 and some weather data from those locations and some historical information of the lines. And we use that to make a machine learning model, specifically XGBoost. And what that model does is it will predict 2, 3, 4 years from now what the vegetation is going to look like. That way they can better schedule their maintenance plans and make their maintenance plans for more proactive action. And as of now, we have our model at a percent error of 16.57%, which is actually pretty exceptional with the lack of data we have and with it being vegetation because it's very unpredictable.
And I'll let Abril talk a little bit about the dashboard.
So we also built this dashboard that you can see a little bit more here, in which you input the year you want to predict for, and it can be any year down the line. And it's going to output two tables. It's going to be the risk by work zones and another one by circuits. It's also going to give you that map where it's going to be color code the circuits depending on the amount of work zones that are in there, in which vegetation is within a certain amount of feet within the line. The ones that are labeled red, most of the vegetation is within 4 feet, which means they're probably going to need to trim the entire circuit very soon.
Awesome. Thank you guys. All right, now we're going over this way. There she
Alrighty. Now we have a table over here with a super
right.
cool setup. Could you guys like to go and introduce yourselves?
So my name is Jean-Claude Lev, Senior Mechanical Engineering. I'm here with Protocol with my team. Our project here is basically taking a standard FDM printer and giving the ability to post-process and have full cycle automation. So typical FDM parts have very visible layer lines on the poster. What we do is our project's able to take that, sand the surface, reduce the layer lines to 76% surface area reduction, do all that in a cyclable loop. So there's no manual intervention. You can start the thing up, it'll print, it'll post-process, and it restarts for 10 to 20 cycles. You can walk away, go get a drink, and then come back and all that piece is ready.
That's awesome. You guys want to show us the setup you have going over here?
So currently here, we have a printer. So our printer here is, again, standard FDM printer, able to add on to existing printer solutions. We have an elegant closure. It's on our ramp. So when it knocks off the print, it's going to fall down the ramp into our bucket where you collect it. On the sides here, we have electronic boxes. These handle communication. So you're able to, from your computer here, wirelessly control our system from your laptop. You could connect on your phone if you want to, able to send commands to it, all wirelessly, no cables required.
Wow, that's super cool.
Well, you can see we have a lot of demos here for keychains. We can have half the surface sanded and half the surface still have those visible layer lines to have that texture on specific places if you wanted it.
Awesome. Thank you guys so much. That was super cool. And we're handing it over to Jack.
All right. Could you introduce yourselves for me, please?
Sure. I'm Sean Legier.
And I'm Jack Marino.
Sorry.
I'm George Kojeta.
Awesome. And could you guys tell me what you've been working on for the past year?
So we are Endovision. We're an additively manufactured curved endoscope for a Zenker diverticulum. A Zenker diverticulum, if you don't know, not a lot of people do. It's a curved sac that develops at the back of the esophagus that collects food and causes you to regurgitate that food, and your breath smells pretty bad all the time. So it's a problem, and 2/3 of people have to go in and to an ENT surgeon and cut that open with a laser using a Dolman scope, which is just a straight endoscope. But 1/3 of those patients, their anatomy does not allow that scope to reach. So they have to do open surgeries, and that is obviously more invasive and not wanted and not necessary. So we decided to develop Endovision, which is a scoped laryngoscope that can reach that intended anatomy.
Awesome. And what's been the hardest part of this project for you guys?
Well, I'd say that since we're working with a bunch of doctors and surgeons, we don't really have any background in the medical field at all. So the hardest part was learning what they needed fixed and being able to put in an engineering mindset, sort of. So
awesome.
Communicating between them.
All right, thank you guys. And we're going back over this way to Blair right here. All right.
Alrighty. So here we are with our next group. And can you go ahead and introduce your group a little bit?
Hi, so we're Cardiacs. We're a wearable EKG device. Right now we have our team member hooked up and you can see her live heart rate data right there.
Awesome, super cool. What was your guys' favorite part about this project?
Honestly, the cross-department collaboration. We worked with the biomedical engineering department as well. So it was really nice to get a full view on things.
Awesome, super cool. And now we're gonna head back over here towards Jack. We're kind of crossing the sea, so I'm just going to talk about my favorite project so far. I really like how they have the power lines up there. I also like how, I really liked the scuba one, I will say that. Especially being in Miami, it's so cool to see how you can do something under the water like that. And that's pretty special about the College of Engineering here, so.
All right. Hello. You guys came all the way over here. Could you guys introduce yourselves for me, please?
My name's Angie Montero.
My name's Kaylee Diaz.
My name's Andrea Nieves.
And could you guys tell me about what this contraption is in your project and all that?
Of course. So Gatekeeper is designed to reduce the fall risk in the elderly population. Currently, falls are the leading cause of injury and death in adults aged 65 and older. So we're trying to target and reduce the decline in muscle strength, balance, and gait. The dorsiflexor muscles are a set of muscles that are in front of the lower leg, and they're basically responsible for lifting your foot off the ground. So you want to increase the strength of those muscles and increase the foot clearance. So currently, there's no technology out there that allows for controlled targeted resistance for dorsiflexor movement with measurable feedback. So that's kind of what we come in to address that gap. Our key features is a pneumatic-based dorsiflexor targeted device. It targets those muscles. It has adjustable resistance so that you can personalize the therapy depending on the person. And it has real-time data tracking and visualization so you can measure the progress. So we have two main sensors, a distance sensor and a pressure sensor that are constantly getting data. And then from that, we can extrapolate the velocity and the force and the power and have a power output, which is very important to basically measure not only the resistance, but also the speed of the movement and have long-term power plateau training. So I'll pass it over to Kaylee so she can kind of explain.
Awesome. Okay.
So now we can go into sort of like the functional blocks if Andrea wants to demonstrate.
Oh, wow. We got a demo. Okay.
We're doing a live demo right now.
This is the first functional block of the solution. So this is the actual patient interface mechanical part of it. So what Andrea is basically doing is she's keeping her heel planted and lifting her toes to the sky. And that is essentially what she's talking about when she talks about dorsiflexion. So the way that we're getting pneumatic resistance here is through this, thank you for pointing, through this pneumatic piston. So it's inputting air right there on the foot pad. And that's powered through our pneumatic electrical system over there. So essentially that's where we do the onboard calculations for the derived values that Angie was talking about. We have a pressure regulator and an onboard compressor so that we can give a variety of different pressures for specialized and personalized training. And then the last sort of layer of the platform is we have an app with data visualization and also gamification. So you can see the output of your reps as you do them. It'll show this like power bar graph. It'll show every single rep. You can see your peak output because there's a strong correlation between patients being able to see their reps in real time and having better outcomes. And then lastly, we have the gamification layer, which is basically a little soccer game that connects to the quality of your reps. So just something to maybe help with patient compliance down.
Yeah. And have you been testing this with people, and has it been showing signs of improvement?
Yeah. Do you want to talk a little bit about that?
Yeah. So we actually we did some usability testing with some participants. And as we can see in this graph right there, 80% was recorded that was comfortable. So basically participants felt like they found it easy to do reps and sets of it. Then we also have that clarity of instruction. So the patients were able to just hop in and use the device without having to get like a lot of instructions. Then we also have muscle activation. So a lot of our participants felt what you call the burn in the muscle complex in the tibialis, which is the gait complex that we're trying to target. So with all these kind of like results, we really solidified our mechanical design, and it kind of like it solidified the idea that we could kind of like get accurate real-time biomechanical feedback from it, and that it's a strong commercialization competitor. So.
Awesome. Thank you guys so much. All right, now we're going over this way. Back to Blair.
Alrighty, here we are at our next table. Can you introduce yourself and tell me a little bit about your project?
Hi, my name is Maria Waterhouse, and this is my senior design project. I created this app called DorsipApp. So the idea is for those people who have muscle atrophy issue. So the idea for them is to ease them in the mobility. So those people who have moving the ankle and they cannot lift upward too easily because they cannot get the mobility too easy. So the idea for them is to be able to walk and to avoid compiling. So I got the raw data from my friend from the other team. So I was able to get faster distance in time as the input. So in order to get the biomechanical output, I was able to get two main areas, training and testing. So I was able to use force, velocity, range of motion, power. And then for the testing, I was able to get one repetition maximum, power stretching, and muscular endurance. So the main idea of this app is for those elderly people who have issues of moving their ankle. So it allows to have better performance across time. So the idea of the app is for both patient and clinician. So in order to get the pulse, I was able to get pressures on the area. So the pressure came from the raw data. And then for the velocity, first of all, I need to get the second Newton law. And then in order to get the second Newton law, I need to convert into acceleration. And that acceleration work for the velocity. So in order to get the velocity, we start the initial velocity from 0, and then I add 1.5 times acceleration in time, which is good. And I was able to get that in the. And then for the force, I was able to combine both parts, velocity and that. And then for the range of motion, the idea is you lift up, well, as you can see in figure 2. So in figure 2, you can see how the schematic drawing for the dosification movement of range of motion work. So you can see the theta by using the law of cosine as the trigonometric feature. So in here, the law of cosine you can see in the graph is in orange color across repetition. And then in order to get the alpha, it's the bottom of the hill, and then you have 90 degree at the right triangle minus theta, then you get this alpha. So therefore, you can see the workflow. If I have in orange color, you can see how the app works. First of all, I select training because it goes for this. And then after many trials you did, then you can get this assault. So clinicians can able to download in the computer on the phone that assault sheet, and then they can save it for future research. And then after that, I was able to get the testing, which is the 1 repetition maximum. So for the 1 repetition maximum, I was able to get the weight of the foot, and then I have 1 plus how many repetitions, it doesn't matter how much, and then you divide by 30. And then for the power setting, doesn't matter how many repetitions you do it across several trials. If, for example, trial 1, I have 2 repetitions, then trial 2, I have 10 repetitions, and then I add this together by the number of trials in order to get the power setting, and then I get the percentage across the trial. And then the molecular endurance, I was able to get this equation, which is two times distance and how many replication on that, and then the mass times gravity, and then divide by time, and that. And then I was able to get that feature, as you can observe in this app. Thank you very much for your attention. For future improvement, I can able to get more raw data for clinical research, and then I need real time in order to work with the app. First of all, I was able to get short data worksheet in order to upload into the app, and then for clinical validation in the testing, it is better in the future to have Bluetooth system because we are using the phone. So as a deaf and hard of hearing person, I use the hearing aid, and I have the Bluetooth setting, and I see everything across every day. So it's much easier for individual and clinicians to see the one.
Awesome.
Yeah. Thank you so much for your attention.
Thank you so much. And now we're on to Jack right here.
All right, can you introduce yourself for me, please?
I'm Maxwell Casenza. I'm part of Team Eris.
Could you tell me about your project?
We built a quantum-based random number generator that you could independently verify. We shot a laser through a magnet, and according to quantum physics, the polarity shift should be random. So we measured that, and we used that random data for a bunch of different applications: financial analysis, blackjack, cybersecurity.
Awesome. What's your favorite part about the project, Ben?
Working with my teammates, they're all great to work with. They're creative, and just finding solutions to problems together. It's what being an engineer is all about.
All right, awesome. Thank you so much. All right, and we are headed over this way. All right, she's over in the corner here, guys. Okay.
Hi, guys. Okay. And I'm with our next group. Can you guys go ahead and introduce yourselves?
I'm Morgan Ford.
Akshay Jha. I'm Devin Elegazabal.
Awesome. Can you guys tell me a little bit about your project?
So we are ZFit. Our project is a bioimpedance-driven prosthetic socket system. Basically, we focus on lower limb amputees as their limb volume will shrink throughout the day. It might start off a little swollen, but as they walk on it, it'll shrink, meaning that their socket won't fit as well. So we wanted to create a system that automatically adjusts for them. That way they don't have to tweak with it or take it off throughout the day, and basically simplify that process for them.
Cool. And why did you guys pick this project?
At the beginning of the year, we were kind of thinking about different needs in the healthcare system, but a lot of us had an interest in prosthetics. So we decided to focus on something that is a typical problem for a lot of amputees, but something that maybe can be a little bit more widely used, especially in lower income world and places that don't have a lot of access to healthcare.
Awesome. Thank you guys so much. Now we're headed back to Jack.
All right. Would you introduce yourself, please?
Hello, I'm Devin Gonzalez.
This is cool.
I'm Dylan.
I'm Alex. All right. Okay. Could you guys tell me a little bit about your project?
Of course, this is Pet Pal. It is a smart dog collar. Essentially, the way it works, it would just be a dog collar. You clip onto your dog, just like the one we have right here. It's not really this one, but it would track the dog's heart rate, the body temperature, the steps, the GPS location, and this information will be put onto a mobile application for the owner to see. And in addition, the mobile application would give recommendations, like your dog's been sitting all day, you should go for a walk, or your dog is too hot, you need to let it go inside and let it cool off. We're just really helping owners take better care of their animals. And in addition, there's a huge problem nowadays where 1 in 3 animals get lost in their lifetime with only about a 60% recovery rate. So with the GPS location, you know where your dog is at all times, no matter how far they are.
Is this something you'd have to recharge? Like, is it rechargeable? You got to take it off at night or something, or is it got a long life battery?
Yeah, no, it's something that has to be charged. The battery life right now is about 8 hours or so. We're trying to bump up those numbers, but yes, it is chargeable.
With battery technology, I think you'll be fine. It's ramping up. All right, awesome. And what's your favorite part of the project, Ben?
Favorite part of the project. You got a favorite part of the project? Favorite part of the project.
Oh, favorite part of the project? Learning all the things we learned from doing the project. Learning how to do electronics, learning how to do 3D modeling, learning how to make commercial grade electronics for this thing, and also just doing something to make dogs' lives better. You know, being able to take care of dogs is something I care about. I love my dog. I know he loves his dog and he loves his dog, and I think it's a great thing.
Awesome. Thank you guys so much. All right, back over to Blair.
Okay, I'm with our next group. Can you guys go ahead and introduce yourselves?
Hello, my name is Francisco Ortiz.
I'm Diana Silverio.
I'm Lorenzo Contreras. Together we're Flow. We did a project on facility logistics and operations workflow. We worked with a company here based in Miami and Doral. What they do is that they ship packages over to Honduras and El Salvador, which is what their main client base is. So what that pretty much happens is that their clients order their packages to their warehouse in Doral, and then they're sorted through, they're processed through the warehouse, and then they're shipped out back out there. So what our project was to try to reduce the overtime hours worked. So what would happen is workers wouldn't be able to meet the demand of packages that they had to get through, and so that would cause them to work overtime. We did an investigation of just where the bottlenecks were by doing time studies, interviewing the workers, seeing where they found difficulties. Then from there, with all that data collected, we made an arena simulation. Then that gave us a baseline of the results. From there, we had our 4 proposed scenarios, and we tested those 4 proposed scenarios and compared the results for each of them. In the end, we went with one where we had it separated with 2 stations, cubic station and labeling station. Cubic station is just processing the packages and scanning the packages to get an idea of the dimensions and weight of the packages. Then the labeling stations is just to label them to know where they're going. So our end goal was just to increase the throughput, which is what we ended up doing with 13% increased throughput.
And we were able to do that with no implementation costs or extra labor requirements. So the company doesn't have to hire anyone new. The company just has to fix their workflow, like our title already cites.
Awesome. Thank you guys so much. And now we're going over here to Jack.
All right. All right. Could you introduce yourself?
Hi, my name's Andy. I'm a senior here at UMiami. I study aerospace engineering.
All right. Could you tell us a little about your project?
Yeah, so we're HUGS. We're a humanitarian utility guided system. We are a rocket-based delivery system that travels at 600 miles an hour and can carry a payload capacity of about 10 pounds.
And what do you plan on using the system for?
So we can use it for people that are lost in remote areas such as forests, deserts, or we can use it for military bases. If there's soldiers that are lost and can't have access to, we can send our delivery systems and send the humanitarian aid directly to them in a very safe and fast manner.
Have you done a launch before with one of these HUGS rockets?
Have I launched?
Yeah, have you launched one like a prototype?
Yes, so this rocket right here that you see to your left is the rocket that we launched back in January. This rocket went 160 meters in the sky. It went up to a speed of 60 meters per second. We tested our dual deployment system and our custom printed electronics. The payload was not ejected yet. We are going to do that for future flight, but the parachute did come out and it recovered safely.
Awesome. All right. And what was your favorite part of the project been so far? Actually, what's the hardest part of the project been?
So the hardest part of the project was creating a rocket with forward-based fins. It introduced a lot of things that I wasn't familiar with before. I had to use a lot of the fundamentals of aerodynamics concepts that I learned in class. Shout out to Dr. Dano. He helped me a lot with the equations that we had to use, the simulations that we had to run. We haven't ever in this history of, not the history, but in the past 2 or 3 years, we haven't launched an actual payload out of a rocket. And we are going to do that soon, which is really cool. We also printed our own custom printed circuit board electronics, which you can't see because they're using right now, which Alex did and we've never done before. So that was really cool. We also made a custom wind tunnel, which was really awesome. We're actually simulating right now, but again, you can't see it because it's being used. And yeah.
All right, awesome. Thank you so much.
Yeah, thank you. Appreciate it.
All right, back over here to Blair.
All right, I'm over here with a super cool looking leg. So if you guys could tell me what your names are and something cool about your project.
Hi, I'm Nikhil Karna. I'm Charlie McDonough. And we are Real Rehab. We've noticed that patients aren't very compliant when they're performing their physical therapies at home. And our solution to this is a sensor-equipped knee brace that provides them with real-time feedback during the exercises. And it also provides physical therapists with analytics and monitoring tools so that they can stay informed in how their patients are progressing.
So our combination of sensors allows us to track full leg orientation within 3D space, including things like tremors or very small movements, even like left to right leg deviation.
Find anything interesting when you were working on this project?
I just think building the brace, we didn't really have the best expertise when it came to building something like this at the start. And I think it's been just such a rewarding process learning how to do this, failing iterations to this. It's just been really rewarding and exciting.
Awesome. This is super cool. Thank you, guys. Now we're headed back to Jack.
All right. So could you introduce yourself for the camera, please?
Yes. Hello, everyone. My name is Dylan Thompson, and my team, we're called Planted.
And what is Planted about?
So Planted is about relieving plantar fasciitis. Our device is targeting plantar fasciitis over time and really getting in and breaking up the fascia.
Awesome. So my mom actually has plantar fasciitis. Could she use your products like now to work on that problem?
Yes, she could use it now. One thing that our device really encompasses is that it's at home, fully automated, so that your mom, and other patients as well, they can just sit back and relax while the device does the therapy for them.
Awesome. And is it like a permanent solution eventually? Like you completely solve plantar fasciitis, or is it like only take it away partially?
So it's not a permanent solution, but it's definitely a therapy that helps relieve pain over time. Like usually right now on the market, there's only ball rollers as well as other devices that really don't really break up the fascia and relieve pain over time. So
awesome. Thank you so much. Yeah. All right, and we're gonna go over this way, get a little interview with the dean real quick.
Hello, I'm here with the provost and the dean. And how have you felt about this Senior Design Expo?
Amazing. This is truly something to behold. You have to be here to enjoy and feel the energy. It's truly, truly exciting. Yes.
That's awesome. Have you seen any projects you super love?
I've seen several of them, and I can't pick one. I mean, they're all really, really incredible. So proud of our students and what they've accomplished.
That's awesome.
Could you introduce yourself for the camera, please?
Hi, I'm Priscilla Ceballos. I'm a senior in architectural engineering, and I'm presenting my structure that I designed for senior design.
Can you tell me a little bit more about your structure?
So we were given the client, public supermarkets actually came in and introduced themselves and said, we have this existing site and structure that was built in the 1960s. How can we make this plot more profitable? How can we better utilize this space? And we did the research and said, actually, we can upzone, so essentially build bigger building, add residential apartments, and create more income and a larger Publix for our client.
And is this close to campus? It's in Miami?
Yes, it's relatively close. It's in the city of Miami. Yeah, it's on Southwest 27th Avenue.
And are you planning on demolishing the current Publix and building from scratch? And how many stories will it be?
So it would be 8 stories, complete demolition. First floor will be Publix supermarkets, 3 floors of parking, and then 4 floors of residential. We have 40% affordable housing. That's to meet the state statute that let us upzone to do that 8 stories.
All right, awesome. Thank you so much. All right, and we're heading over this way to Blair, I believe. Yeah, right over here.
Alrighty, I'm over here with a super special table. And here we are. Could you guys do me a favor and introduce yourselves real quick?
Hello, my name is Emilio Reyes.
I'm Emily Zhu.
I'm Laureline Costa.
I'm Adam Booker.
And tell me about your project.
We're SnapSense, a long snapping workload monitoring device looking at fatigue and acceleration and velocity based on the amount of reps I have. It can prevent overuse injuries by looking at my workload and seeing how my velocity decreases over time. So we're going to do a live demo for y'all as well.
So this is the app. So you'll see as he snaps, there's more and more reps. This is the overall summary of the amount of reps that he does, and this is the live fatigue graph. So obviously over a lot more snaps, he'll have a lot longer of a fatigue graph, and you'll really see that decrease. But over such a short session, you'll end your session, and here you'll have your summary. So you have your beginning where you have your total amount of reps, good reps, and then flagged reps, and then your fatigue graph. And then you have some more data. This is mainly interesting for us, accelerometer and gyrometer. And then your final breakdown. And this is awesome.
All good snaps, by the way.
Yeah, they were all good snaps. And then you have your final total sessions, which is really great for a total view.
Awesome. Thank you, guys. What was the most challenging part about the project, you would say?
Learning how to program the actual device, and on Laureline's part, how to program the app.
Yeah, that was definitely it. That's specifically learning how to code, especially as mechanical engineers. Big challenge, but really, really insightful, super interesting. Very exciting.
We learned a lot too, right? I mean, we had never had much experience with coding before this, and we actually learned a ton. So it was great.
Awesome. Thank you, guys. That was super cool. Now we're going back to Jack over here.
All right, could you introduce yourself for me?
I'm Nate Perrin.
I'm Doug Holden. Liam Whalen.
Could you guys tell me a little bit about your project here?
Yeah, so Formula SAE is a student design competition where students build Formula-style race cars. University of Miami just started a club here on campus, Canes Motorsport, and we were tasked with building the first Formula SAE chassis at the University of Miami.
Awesome. And can you tell me a little bit about that process and how it went for you guys?
Yeah, so we started with a few base models, taking out a lot of members for the front bulkhead, side impact structures in the back. And we kept building on it and testing in our FEA simulations and turning it into what it is now.
I'm gonna wait. Yeah, we're gonna head over this way. Thank you guys so much. All right. Excuse me. All right. Back to Blair.
All right, I'm with our next team. Could you guys go ahead and introduce yourselves?
Hi, I'm Mendel. That's Jesse. That's Jackson. That's Naroa. So we're Team Detectalepsy.
And tell me a little bit about your project.
So we're trying to predict epileptic seizures in advance so patients can get to a safe place in time and prepare.
Awesome. So what was the most challenging part about your project, you would say?
Definitely finding the experts to help us, because this is like a brand new field for all of us, and finding the experts in breath analysis, the people who can actually like build these kinds of sensors was really hard, but we got really lucky with our mentors, Dr. Takichi and Dr. Donnert from the biochemistry department at the medical school. they helped us a lot. But that was the hardest part.
Awesome. Tell me a little bit about your device. What does it do?
So it's going to be a wearable device. Right now it's a little large, but we can make it smaller to be a wearable pin that you can wear on your lapel that's constantly reading your breath and detecting these volatile organic compounds from your breath that are biomarkers for a seizure and hopefully predict a seizure up to an hour in advance.
Awesome. Thank you. That's super cool. Thank you guys so much. Now we're going over to Jack.
All right. Could you introduce yourself, please?
Yeah, so this is Yusuf Al Hindi. I'm computer engineering. Yeah, this is our booth and this is our friend. We all built in Super App.
Could you tell me a little bit more about it?
Sure. Our app called Curve. So it's basically in Super App. Imagine that you have in DoorDash, an Instacart, Walmart, and any gym membership in one app. So this was our idea. We had to combine everything in one app, and the only one special thing that make us our app really super and special is, have you ever heard of Factor?
Yeah, the meal plan.
Yeah. So we have there is in multiple concept like Factor. So we combine it all in one app, and we can basically calculate your BMI, and based on your calorie, we can recommend which best food package that fit your diet. And then after you subscribe, you can manage daily your food intake, and you can shuffle any dish you want. You can add any registration, like we don't eat pork or something.
And what are your future plans for this project?
Yeah, so our future plan is to get this app license here, and then to put it for investors so that they can take it from there. And yeah, I think that's our future plan.
Awesome. Thank you so much. All right, now we're heading over this way.
All right, I'm here with our next group. Could you guys go ahead and introduce yourselves?
Hi, I'm Abrar.
I'm Salem.
And tell me a little bit about your project.
So we worked with Kutaya. They're a tile manufacturing company in Turkey, and they just recently opened their first branch in the U.S. here in Miami. They've been operating for about a year, and they're like a startup company here in the U.S. So they've been having issues managing their customers' data, their sales activity, and other stuff. So we built them a CRM system where they can manage all that data. And also one of the cool things is the discount calculator that we made for them, which, they base their discounts for each customer differently based on their own criteria. And before they used to consult management on that decision. But now they can immediately see it through the system that we made. And then they'll get the discount immediately. And that's more efficient for them.
Awesome. And what was your guys' favorite part about this project?
Coming up with all the stuff that we could have come up with so many different stuff, but Excel is fun to use, and it was just
That's an awesome engineering thing to say. Thank you guys so much. Now we're going right back to Jack.
Okay. Could you guys introduce yourselves, please?
I'm Jess. I'm Emma. I'm Courtney.
I'm Maria.
I'm Aldo Wang. Could you guys tell me a little bit more about your project?
This is our stormwater master plan for the village of Palmetto Bay.
And what does it entail?
So it entails addressing the flooding issues within the village, where we address their inadequate drainage infrastructure, and we just wanted to make it better.
And what's your favorite part of this project, Ben?
So what's different about our project is we have 3 different design innovations. So one of those being the presence of a canal in the middle of our subbasin. So we're proposing a weir in order to combat the water quality issues in our area.
Awesome. All right, thank you guys so much. All right, and we're gonna head over this way.
All right, here I am with our next team, and I'm going to have them introduce themselves real quick. All right, what are your guys' names?
Hi, my name is Samuel. Guys, we're being interviewed.
All right, what are your guys' names?
So I'm Luca, and this is Samuel. We have Pedro here as well. I don't think Ryan's around right now, but we're the 4 people that are in the... Yeah.
We have another group member. What's your name?
I'm Ryan Rodriguez.
Awesome. Could you guys tell me about your project?
Yeah, so we're making a helmet cooling system that for the broader motorsport category, but in F1 it might work as well. That's mainly based off of what drivers will want, or based off of feedback from the FIA. We are basically making a system for our helmet that has a comfort liner, that is able to be taken out of the helmet because we don't want to mess up the integrity of the helmet. We have thermally conductive tubing that has a propylene glycol mixture that is used to extract heat from the driver's head during ambient temperatures up to 125 degrees Fahrenheit. So basically, we're just trying to cool drivers' heads down.
And what was your biggest challenge in this whole project?
Basically, the weight was the hardest challenge. We started actually with an air type system, but as you can see here, it is a huge system. It's not really practical for implementing into F1 and motorsport in general. So because of the recent mandatory implementation of active cooling systems into F1, we saw an opportunity to extend the pathway of the coolant into the helmet. So that was our biggest challenge, essentially.
Awesome. Thank you guys. Super interesting. And now we're going back over here to Jack.
All right. Could you guys introduce yourselves for me, please?
Yeah, so I'm Jonathan Mendoza. I'm electrical engineering.
I'm Alec Bronsky. I'm software engineering.
I'm Troy Brown. I'm computer engineering.
Could you guys tell me a little about your project here?
Yeah, so our project, TerraLink, is a dual layer message network relay device. Basically, it aims to solve the problem of Wi-Fi connectivity and any communication in rural environments.
So, I mean, well, I was wondering what you plan on using this project for. Like, are you planning to use it for military applications, rescue?
So literally all of those. You could use it for camping, hunting. The Red Cross could use it. The military could use it. Because basically what we do is we take, think of a hotspot, Starlink, any internet router. We connect it to our host device over there, and it bridges that Wi-Fi connectivity to our other node devices all the way up to 3 miles.
So it extends the network of the Starlink? Or,
yeah,
like,
or any internet router. So all the way up to 3 miles, and anything beyond that, we have it where it will automatically switch to a different Wi-Fi protocol called LoRaWAN, and it will be smaller bandwidth, so we will have to send smaller data, but it will be longer range. So you could configure the LoRaWAN or the Wi-Fi Halo to whatever user needs. If you need to send a specific type of data, you could configure it to that.
What's the maximum range on that lower bandwidth?
On the lower bandwidth, I believe it's all the way up to 5 miles.
Yeah, that's awesome. All right. Thank you guys.
I have some more if you want. So typical industry products are range from $2,000 to $5,000. Our device, it comes in at a price point of $150 per device, which is significantly lower. It's very portable. You don't have to carry around a bulky router, and the battery life per device is up to 8 hours. And what's special about our product is depending on the battery life that each node has, it will pick the higher battery life to ensure that you get the highest connectivity and that you receive the information that you need to receive.
All right, thank you guys so much. Now we're going to head over this way. Oh, over this way.
All right, I'm over here with the super special industrial engineering group, and I'm turning it over to them.
Hi, so my name is Priscilla.
I'm Andrea.
And this is my partner, John.
Hi, I'm John.
So we want to give you a quick overview of what's going on at Mount Sinai Medical Hospital. So what's happening is this kitchen's in charge of delivering meal trays to patients. But if those meal trays are coming in incorrectly, then that causes an issue for all patients that have dietary restrictions, are about to go into surgery, and overall want to make sure that they're increasing patient satisfaction. So over here at the process, we're able to take a look that we have a hardworking team, but their efforts are allocated to non-value added time. So what we did most importantly was data collection. We measured every single time cycle. We want to analyze everything, measure all the components, and we want to make an arena to simulate everything. So here we actually have an image that can demonstrate that we're going to take away one worker from the future current state, and we're going to turn them into a floater position. Now, right now, what they're assembling is they have a tray in front of them, but the materials are behind them, which causes an issue of having to turn around excessively. We're going to change that, and we're going to implement them everything with an arm switch in front of them. Additionally, we're going to implement KDS screens, which help implement a recommendation of having to see everything visually. Okay. So as a result, we were able to do one fewer worker per every 9 employees. In addition, we were able to take the time cycle from 3 minutes to 1.5 minutes. That 50% is going to directly translate into error proofing. So what that means is we're going to have more accurate trays, we're going to be able to catch quicker mistakes, and most importantly, we're going to save labor efficiency. What does that mean? Last year, we recorded 3,000 hours, and we're going to be able to reduce that. On top of that, we were able to reduce our turnover rate by 40%, and most importantly, keep up patient satisfaction, which is the motto of Mount Sinai.
Thank you, guys. And what would you say the most rewarding part of the project was?
Working together as a team and start early, honestly. It takes a lot of time.
I think the most important was seeing the workers at the hospital be overly excited about our solution. I mean, they're excited to start seeing a more efficient process in their everyday work life. So that was really important to see.
Yes, it's knowing that like the change that we make can impact a hospital in a bigger way, because also these changes that we make can be put into other hospitals as well instead of just Mount Sinai. So it's knowing that we can impact people that are outside of even Miami as well.
Thank you.
Thank you very much, John Ham. Now we're moving over to Jack.
All right. Could you introduce yourself for the camera, please?
Yeah, so my name is Emilio Canales, and we're part of Group 35.
Can you tell me a little bit about your project?
Sure. So we tried to make a Band-Aid made of a microneedle hydrogel that's able to give you, able to detect infections early on to help you get treatment.
Do you have a sample you can show on the camera?
These are the hydrogels themselves. So this is in a pH of 4, which mimics healthy and normal like skin. So like his skin right now is around a pH of 4, but if it was infected and full of bacteria, it goes up to a pH of 8 and it turns clearly blue. So that'll help immunocompromised patients, especially cancer patients and elderly, in order to go and get further treatment.
Have you tested this on people?
Not on people, just because that requires a lot of money and also like
putting bacteria
certifications and stuff. But we did try it with different buffers to make sure it has a good gradient of color change.
And do you have future plans to try and test it in medical applications?
Yeah, hopefully. We do work with a lab that have done it before, so hopefully, like with their guidance, we're able to test it on real people.
Awesome. Thank you so much. All right. Now we're going over this way.
All right.
All
I'm
right.
with our next group, our final table. All right. Can you guys introduce yourselves?
Hello, my name is Andre Salato.
Come over here
My name is Miles Sanders. I'm Xavier Robertson.
and tell me about your project.
Okay, our project is the Solar Electric Aircraft for Meteorology, or SEAM. Basically, when it's Florida and it's hurricane season, a lot of rain, a lot of thunderstorms. So what we designed was a solar-powered UAV, or AI autopilot vehicle, designed to fly up and map these storms, all the data for it, so that we can get better meteorological data and not rely on old weather balloons or just asking pilots to risk their lives for storm data, and basically get a better mapping of the storm, how they form, and be able to get this data to people that actually need it. So emergency crews and people like us that are just trying to wait and see if the weatherman's right today.
Awesome. What was the most challenging aspect of this project, you would say?
So a lot of the challenges came from just building a model for this aircraft and testing it. So when we're trying to test this aircraft and everything that we have, it just comes back to, can we actually do this with a computer? Because it's a lot of data and we're running on student licenses. It's a lot of stuff. And the numbers that we're using, because we have to fly at 60,000 feet or 40,000 or 80, we have to fly very high and get accurate numbers for this. So we have to get down to decimal points. We have to do a lot of math, and that math tends to add up over time. So changing one number can change half the aircraft, and just trying to get all that lined up and right, a lot of work.
Awesome.
On top of that, because the aircraft was so large, we actually crashed the computer several times trying to test it. So it was a big problem.
Awesome. Thank you guys so much. Now we're coming around over here back with Jack.
All right. That concludes 2026 Senior Design Expo. So thank you guys for watching.
Thank
and
you.
Maybe we'll see you next year.
They
So,
work
yeah.
super hard. Good
Yeah.
job, guys.
Thank you.
Hello, everyone. We have 5 more minutes and then we're going to close the voting. If you didn't get the email and did check in, please check your spam. So I'm going to go ahead and I'm going to invite Dean Amachanu to the stage so that he can welcome everybody. Thank you.
Good evening, everyone. All right, your attention, please. On behalf of the College of Engineering at the University of Miami, I am delighted to welcome all of you to this special event. I want to thank all of our industry partners who have taken time off to be here today. Those of you who have served as judges for this occasion, I thank all of you. Without your participation and input, we would not be the College of Engineering that we are today. So I am grateful for your presence. I'm grateful for your enthusiasm and passion for this university and for the college. And now I want to thank the faculty. Faculty members in the College of Engineering have been an active component in this entire process. And the students would attest to the fact that many of these projects were shared with faculty, and faculty input played a major role in the success that you all have witnessed tonight. So thank you so much to our faculty. This is why we seek to employ and attract the best minds from all over the country when we're recruiting faculty members. This is where it shows up. It shows up in the quality of the work. It shows up in the passion that you bring to bear in making this a success. So thank you so much. And now to the students. Aren't our students great? What do you think? Our students are amazing. Yes. Before I talk about our students, I want to talk about the Expo committee. When we come in and experience what most of us have experienced tonight, it is very hard to imagine the work that went on behind the scenes to bring this to bear. So I am infinitely grateful to members of the Expo committee for the countless hours that you have all invested in making sure that this event actually takes place. My gratitude to all of you. Thank you so much to the members of the Expo committee. I also want to take a quick moment to acknowledge members of the Dean's Advisory Committee. I know we have something on the Dean's Advisory Committee. I want to hasten to recognize this group. Now, for every college, for every school here at the university, we lean heavily on this group of people that you see behind me. They donate so generously to making the college what it is today. But aside from the donations, we are beneficiaries of their wisdom and experience and passion for the college. They participate in much of what we do. They not only lend us their ideas, but they also lend us their thoughts and their minds. So if you're a member of the Dean's Advisory Committee and you're in this audience, may I ask you to please show your hands just so that we could acknowledge and welcome you. Yes. Thank you so much. Let's go back to some of the others. The sponsors, I think. All right. I want to thank the sponsors of this event. I think we have that coming up here. Thank you to the sponsors and those who make this possible. You can see their names here. Thank you for all you do. Rider System, FP&L, the Alumni Association, People's Choice Award, and the rest. So our gratitude to our sponsors. Thank you for making this happen year after year. We appreciate what you have done and what you continue to do. Your support is invaluable for this college and, for that matter, for the university. So thank you so much. That's it, right?
So now we're going to start with the department awards, and if I could have Dr. Gallardo please come up so that we can do the BME award. And Dr. Rajguru.
Great. Hi, I'm Dr. Gallardo Hevia, and this is Dr. Rajguru, and we're representing the BME department.
Woo! BME!
And now for the Outstanding Biomedical Engineering Project, we'd like to nominate Detectalepsy. So please, Mendel, Naroa, Jackson, Reese, please come forward. And Dr. Mons as well. Congratulations.
Thank you so much.
Congratulations. Come here. Wait, where do you get your thing? Let me put. Everyone.
So can I have Dr. Wang please come to the podium?
Dr. Gang Wang. It's my honor to announce best project for CAE department. Goes to 7 pillars.
Dr. Chisoni, we also want the faculty who teach senior design to come up with the teams. Drew? Dr. Rich. Oh, no, you don't need this.
I don't know why so much.
So Dr. Amin will be presenting the award for chemical, environmental, and materials engineering.
Hi everyone, I'm Samuel Amin.
Hello, everybody.
Hi everyone. Let's quieten down. Hi everyone, let's quieten down. Yeah, I'm Samuel Amin from Chemical Engineering, Chemical, Environmental, and Materials Engineering. It's a pleasure to kind of announce the winner from the department, which is Stormwater Solutions. So come up and see why. David.
So we need Dr.
David
Chin and the team to please
Yeah.
come forward.
Oh, David is coming. So congratulations, thank you. Hi, Maria, congratulations. Congratulations. Jess, congratulations. Congratulations. Let me just.
So Dr. Asaf Rajlani will be presenting the Electrical and Computer Engineering Award.
All right, so my name is Hamam Safar Jalani. I'll be presenting the award for the Electrical and Computer Engineering Department. And the award goes to Terralink. Please come up.
Dr. Bensby, the chair, and the sponsor or mentor for the team, please come forward. So I will be presenting the award for Industrial and Systems Engineering. And the award goes to Facilities and Logistics Operation Workflow. Dr. Urkach, can you please come forward to be a part of the picture? Could I have Dr. Jeff Dirk come forward? He's going to be presenting the award for innovation, technology, and design.
So good evening, everybody. I'd like to recognize the recipients of the Innovation, Technology, and Design Award, and that goes to Real Rehab.
Please come forward for your pictures. So I didn't say this earlier, but the graduation medal that these winners are getting is a one of a kind. It says Senior Design Expo winner on it. It's not the same medal that the students will get for graduation. So these are special medals. Congratulations. Dr. Kevin Bootson will be presenting the awards for mechanical and aerospace engineering.
All right, so for the award for mechanical and aerospace engineering, we actually split the best award into two pieces, and the best team is SnapSense for mechanical. Is Dr. Travasio here? I don't know if he's here. Congratulations. I don't know if Dr. Travasio. Dr. Travasio, are you here? No, I don't think so. Okay, so now we're going to go to the best aerospace project. The best aerospace project goes to Team Hugs.
Please come forward.
Where's Team Hugs? They're coming, they're coming.
You guys are slow walkers.
Congrats, guys. Congrats.
So the next three awards that are going to be awarded are awards that the Expo committee determines. And the first one is
The Best Expo Display Award goes to FPL Predictive Model for Vegetation Growth. You want?
Braden knows how to make FPL power poles here.
So the next award goes to the Best Expo Poster, and it goes to Planted.
Dr. Rajguru and Dr. Mons and Dr. Gallardo, please come take pictures with your winning team.
They're here, they're here. Take a picture. Take a picture. So the next award goes to the Best Expo Video Award. So we had all students send videos to us, and it was a very close battle between all the teams. And the best video goes to Z-Fit. There's stairs on this side if you want. Where's everyone?
Right. So call the alumni. So next I'd like to call the president of our Alumni Association, Daniela Martinez. She'll be presenting the 3 awards that they sponsor. Daniela. Oh. She's on her way. So I might as well let you guys know the Alumni Association has for all the seniors tonight a welcome to the club event. So immediately after this on the terrace, there is an event where they're actually serving beer and wine and more food. So you definitely want to stay for that. The Alumni Association for the College of Engineering is one of the most active associations here on this campus. We're one of the few colleges that has a dedicated team. But it's not in order. All right. Is she really? She's in the elevator. It's like the bride who's coming late to her wedding. So do we have any comedians in the group who wants to? Oh, here she is. Come on, Daniela. Hi, Daniela.
Hello, everybody. Sorry for making you all wait. My name is Daniela Martinez. I am the president of the College of Engineering Alumni Association. So it's a pleasure to meet you all. I hope that you all had a wonderful time. Dr. Maville started putting this event together when I was a senior, and I know that my family and friends really enjoyed it. So I hope that you all did as well. So we will have an event at the terrace right after this concludes. So please come join us. It's open to all the graduating seniors. We're basically welcoming you all into the alumni club. So please join us. Yeah, congratulations. Yeah. So the Alumni Association has made it a tradition to present these awards every year. So without further ado, the People's Choice Award for 3rd place goes to HUGS. If you all could please come up, we'll take a quick picture. So the People's Choice Award for second place is actually tied. We have two teams. So the two teams are Commencement Reimagining and IBIS Robotics. IBIS. Congratulations.
Come get your medals. If you want green, I don't mind. And you got to. No, it's all together. Let me get up here. Do you want to do them together or separate? Let's do them separate.
Okay, and the last award of the night, the People's Choice Award for first place goes to Seven Pillars.
So the next set of awards that we are going to have I'm going to invite Dr. Amin and Professor Lokesh for the pitch competition that was held this morning.
Good afternoon, everybody. This is for the Pitch Competition Award, sponsored by the Rothberg Catalyzer Fund. This award is open to the entire university community for innovative solutions. I would like to call Anna and Martha, who are judges of the competition, did the heavy lifting of judging the amazing presentations. Thank you so much. I invite Dr. Machanu joining us as well. Yes. Dr. Benzui, yes. All right. Yes, I'm going to announce all the winners. Please come to the stage, all the winners. And there is a surprise this year where Cane Angel Network by Office of Innovation, they were so impressed by the presentations. They announced $1,000 award, an extra award. And then the other thing is all the teams, they are ready to connect them with real investors. So the Cane Angel investors, will be, if you want to reach out to the Cane Angel investors, their team will be available to help you out. All right. So let's announce the prizes. You all waiting for that? The third place. Oh, it's all together. Sorry. All right. The third place is House AI. The second place is TurboForge. The first place is Stylosite. The Kane Angel Network Momentum Award is for Duolith. I invite all the winners for a picture, please. Congratulations, all the winners. Congratulations. All right. Where is Duolith and where is the TurboForge team? Max? Congratulations, guys. All together, one picture.
So stay up here. The last two are for you. So the first one that you're going to do is industry impact judged by This is the team who won. No, I'm just going to call it two.
Okay. The next award goes to this is the Industry Impact Award. The winners or the participants were judged by industry representatives, and the award goes to Endovision. Congratulations. Congrats. Congratulations. Congratulations. Great job. Yeah, come join.
Yeah, the best senior design. So it's in honor of Dr. Asfor, and this is the best project in the college. It was.
Who's that? Come on now.
Really?
See, I'm positive.
All right. So the last award of the night is the Dr. Shihab asked for Best Senior Design Project. We named this award in honor of our former Associate Dean. He was a faculty member for many years, and he was a champion of this event for us. And so the winner for the best overall senior design project at the College of Engineering goes to Hugs, Humanitarian Utility Guide at Syscrom. You don't get a second medal, though. Thank you. So I want to thank everybody for coming. This year's theme for the event was Decades of Discovery and Innovation. This is our 10th year with the event, and we're very proud of it. Thank you for coming. Congratulations, seniors. We'll see you at graduation. And please go enjoy the alumni event. Thank you.